Hi, I'm Dan from FTNKBIDZ. In this scenario, a YouTube video was streamed on Google Chrome from my device and the data of this network activity was captured and stored in a spreadsheet. Several charts was made to visualize this data. This is a chart for the percentage of protocol transferred. From the chart, the most dominant protocol is UDP. UDP is a lightweight connectionless protocol that provides low latency data transmission but does not guarantee reliability or error correction, which is suitable for streaming video and other real-time applications. Next, this is a chart for the percentage of packets transferred on each IP address with my device. These three IPs are the dominant IP. Let's just call these IPs as IP A, B, and C. After checking the info of these IPs from a website, three of them are all belong to TMNet, an internet service provider from Malaysia. Therefore, these IP addresses are likely belong to an intermediary network devices that are facilitating the video streaming. Based on information in chart 1 and 2, I minimize my scope to the UDP packets transferred between my device and IPA. From the data in the spreadsheet, my device is using a high number port 5529 for the video streaming, while IPA is using the standard secure port 443 for some communication related to the streaming process. 5529 is a high number port that doesn't have a specific role, which suggests that it is used for established connection for this situation, while 443 is the standard port for secure HTTP or HTTPS traffic. Next, this is a bar chart for the number of UDP packets transferred on each seconds. The possible reasons for the absence of UDP packet transfer during the time intervals of 3 to 19 and 22 to 30 seconds could be due to temporary connectivity problems, causing the UDP packets to be dropped or delayed. But it is also possible that the streaming server used buffering techniques that will transfer the packets earlier to ensure smooth streaming, so it will not have any UDP packet transfer in that time interval, since it has sufficient buffering to sustain playback already. These are all the information extracted from the data, and that's all for this scenario. Thank you.
A very good afternoon. My name is TASHVIN and I'm from BITZ S1G2. And today I'll be explaining about the wireshark capturing file regarding the file download file. So as you can see, first I have captured my wireshark file and transferred it into a CSV format or an Excel format. And thus I've made a table. As you can see, the time is in order and the type of protocol and also its length. And then using this data, I have created a percentage table, and thus we can see the protocols and the protocol name and number of packets. As an example, as you can see, TCP has the majority percentage, which is 54%, followed by TLS version 1.2, UDP, and followed by MBNS and DNS. So these protocols are involved during file download. And thus next we can see the packets received in 12 seconds. First, I have created a table using the wireshark file, and also I've included some columns of my own, such as all protocols and cumulative table. This is to see the total number of packets. And after that, I visualize the graph. As we can see, there is a spike in overall at from time 5 to like around 6 to 7. This is because the file download session occurs during this period. As you can see, due to internet limitation, the file download is very small. Thus, there is only a small time period. And then next, kilobyte received in 12 seconds. Again, I have created a table with the information of how many kilobytes that is received. And again, I have visualized by using a graph. And again, we can see at time 6 is where most of the things is happening. And then lastly, I've created a packet size range. This is to see the total from time 1 to 15. That is all from me. Thank you.
Okay, selamat sejahtera dokter. My name is DINESH, BIT S1G2. So I'm going to explaining about the wireshark capturing file regarding the file sharing scenario. So as you can see, I capture my wireshark file and convert to Excel format, and I made a table. You can see there's a time source, destinations, protocol, length, and info in order. So, and using this data, I created a percentage. So at the majority percentage is TCP SSL, that is 62%, followed by TCP 36%, and TLS 1.2 is 20%. So these protocols are involved during file sharing. So next is packets received in 30 seconds. First, I arrange a column by my own, such as all protocols, TCP overall, all figures, overall secure cumulative, and to see the total number of packets. When I visualize the graph, as we can see, there is a spike overall 7 to 9. This is because this period file sharing happening. So next is kilobyte received in 30 seconds. So I have created a table, the information how many kilobyte is receiving. I have visualized using graph that we can see at time 8 to 9. Most of thing is happening. So lastly is I created a packet size range. So I created a table. This is to see the total from time 1 to 13. So that's all for me. Thank you.
So bin SALLEHUDIN, and I'm from the ITZ group S1G2. And today I'm going to do my presentation about our group project, which is the group asked us to do a network capturing scenario and visualize the captured network. And as for my scenario, I choose music streaming. And here are the capture network that I export as Excel. And based on the captured network here are the number, time, source, destination, protocol, length, and info. And from this data, I able to display three things from it. And for the first one is I able to visualize number of packet by protocol. And for music streaming, as we can see, there are several protocols that included. As for ARP, DNS, MDNS, and as we can see, the highest, which is TCP, means that in music streaming, the most protocol that being used is TCP. As you can see, number of packet that users are 519, which is more than half than others protocol. Okay, this is the first thing I able to visualize in graph, which you can see 519. Okay, the second thing that I able to visualize is how many packet received in 30 seconds. Here are the table which it will display the time. As we can see, the maximum time is 30. That the data we able to get it from the captured network, which is 30. And here are the TCP number, the others or protocol, the cumulative. And based on this data, we're able to visualize it, which is the TCP is slightly below the overall cumulative, which is combined of other protocol. And the last one is range of length packet. As we can see, the range length, I range it by 0 until 2,900. And we can see the total NTCP TCP is slightly below than total of overall other packet, which means we can see that TCP is actually quite high because it almost the total of TCP length packet is almost reach the overall of others protocol. Means like TCP is solely the main protocol being used in music streaming. And the application I used was wireshark to capture the network, and the music streaming application that I use, which is Spotify. So that's all from me. Thank you.
Hello everyone, so my name is Aimil HAMKA and I do for scenario which is video conference. Okay, so from here video conference, I've been doing Microsoft Teams for video conference. I do meeting there and then I capture the network for 1 minute using Wireshark, and then I export the data into Excel. So here the data that I can compute from video conference, and which is there's a lot of protocol here that been used, but for the main protocol is UDP and RTCP. This is the major protocol that been used in video conference, right? So and then from that data, so here is the one analysis that have been used, that I've been searched, which is packet percentage per protocol. So you can see here number of packet here. So the UDP is the highest one, which is 3,978. Meanwhile, RTCP is the second highest, which is 774. And you can see here, the graph here. For the blue one is the UDP protocol. As you can see here, the highest number. So the UDP one conclude the 81% from the percentage per protocol. And the RTCP one is the second highest. So you conclude the orange one, which is 16%. And the rest will be 2%, 0%, 0%, 0%, and 0%. So, but they are mostly not in use. They have the lowest percentage in this protocol. Right, so we proceed for the next one, which is packet exit in 30 seconds here. So I conclude for the UDP and TCP, which is the most major protocol that we use. I will conclude for the 30 seconds. So here you can see, such as for 1 second, the UDP protocol make 72 packet, receive 72 packet, TCP receives 60 packet. So from the graph here, we can conclude that for the overall cumulative, the brown one is in 7 seconds, we got 507 packet. 7 seconds only in need. So for the rest from 30 seconds, which is almost 2,000 packet that we receive in 30 seconds. All right, so that's the second one, and the last one is packet size range. So I've been used range for 50, which is 0 to 50, 50 to 100, and 100 to 150, and the rest continue for until 100 to 2050. So for the packet size range here, I can conclude that the highest range for packet, which is from 100 to 150. That's all for me. Thank you.